Good afternoon, everyone. And before we start, can I acknowledge the traditional custodians of the land on which we're meeting and pay my respects to elders past and present. So I hope you're ready for the final frontier. My name's Steve Champman. I'm the Vice-Chancellor of Edith Cowan University. And our speaker today is Professor Alan Duffy. There's a lot about him on your app if you want to look at that, but one of the things I think that's very interesting is that he is the Pro-Vice-Chancellor of Flagship Initiatives at Swinburne University of Technology, and he's searching for dark matter. In fact, he is the chief investigator in the $35 million ARC Centre of Excellence for Dark Matter Particle Physics and SABRE, the world's first matter detector in the Southern Hemisphere at the Starwell Underground Physics Lab at the bottom of an active gold mine in Victoria. Fascinating. And today, Alan's going to tell us about space, a driver for workforce development and economic advancement. Alan.
Thank you so much, Steve. All right, so the world is facing many challenges in this century that require more science and technology, not less. To make the best possible choices on how we address those challenges, we need a scientifically informed electorate. To have them informed, we need to excite and invite them to want to know more. Perhaps even to study it, maybe even to research it, and perhaps for some, I hope, to commercialize it. For all of those activities, one of the strongest drivers that I know of activities down here is up there. 1 billion years ago, something goes bang. With about the energy of a century's worth of our sun's output, all released in the blink of an eye. The light, primarily in radio, travels across the universe in every direction and just so happens to wash over a very famous, iconic radio telescope in Australia. Now, it was in the observatory just one random evening's observing. My colleague, Matthew Bales, was chatting with his old student, Duncan Lorimer. And Duncan said, Matthew, I found this really strange, very bright signal in the archives, just some old files that had been sitting there, data taken years before. And they looked at it and they thought, well, maybe this is one of these newly discovered compact hearts of a dead star known as a pulsar. And it's happened that Duncan's wife, Moira Mulcahy, had just done the analysis on one of these kinds of pulsar classes, and they looked into it, and they pretty soon came to the realization that, no, this was something new, but also this was something incredibly distant. And for it to be so bright that it overwhelmed the receivers of Parkes after this billions of light-year journey, it must have been unimaginably bright. They wrote it up. This is in 2007. The event was known as the Lorimer Burst, and it unleashed a new era of radio observatory or radio astronomy known as transient astronomy, which has now found this new class of fast radio bursts everywhere we have looked. And it has earned the three original discoverers their share in the Shaw Prize announced last year. Now, this kind of incredible discovery that was made by using Parkes, well, astronomers, we just don't settle. We want more. We always want to see the universe better. And for that, we have this extraordinary facility. The day it turns on, it will see more fast radio bursts than in all of our years of efforts to that point. This is the Square Kilometre Array. 16 countries have invested billions of dollars in two unique locations on Earth that have the comparative advantage of being able to see into our galaxy and have this pristine land unpolluted by light or radio signals. They are, of course, South Africa and Australia. In Australia, we will have over 100,000 telescopes dotted across the lands of the Wurundjeri people in Western Australia. And those traditional owners have worked on this program with the directors, the SKA directors, for many years. And I think is an example of an extraordinary collaboration that we are seeing 60,000 years of continuous astronomical knowledge now coupled with the very latest in radio astronomy technologies. This kind of discovery engine will excite and inspire the world just as much as Parkes was able to in its many discoveries. But something this big presents something of a unique challenge for us, and that is the data volumes coming from all of those telescopes is measured in fractions of the internet. That means even with the wonderful facility, the SKA processing center at the Pawsey supercomputer in WA, we can't possibly analyze most of that. We certainly can't store it to reinterrogate the data again in years to come, as we did with Parkes with Matthew's discovery. Instead, we are designing AI systems to sift through that data in real time, flag an event of interest, and then we save it. The AI we design today is going to tell us what the universe looks like tomorrow. No human in the loop at that point. This is a very different era for space sciences. Now, of course, what's exciting is that we're going to design an algorithm, an AI, which can find not just what we are looking for, but what we don't know to look for, the unknown unknowns. And that is going to unlock tremendous economic value in fields far beyond astronomy. Now, how do I know that? Well, because this is what always happens in astronomy. I want to give just some quick examples. The image processing software on the Hubble Space Telescope. Imagine those glorious images you see of the distant galaxies. All of that work was so breakthrough at the time that the algorithm, the image processing pipeline, was translated to mammogram scans to search for cancers. We have examples of tape on board those satellites that NASA was launching in the early years. They pioneered the use of solid-state recorders to extend the life, the utility of their own satellites. Of course, for an older generation, I can't see anyone, I'm not making any statements about this, whether satellite TV played a big part in your life growing up or not. My children watch, ABC, iView, Netflix, you name it, streaming, but this was a revolution. And these kinds of satellite communications, of course, are one of the great benefits that have come from space. And, of course, sat-nav, but I'll get to sat-nav in a bit. My favorite example, though, is one I'm sure is familiar to many, and that is of Wi-Fi. Now, this was discovered, the search for exploding black holes postulated by Stephen Hawking in 1974 was undertaken by the legendary John O'Sullivan. And he created a technique to clean up the signal as he was doing those searches. Didn't find any exploding black holes, but did lay the foundational science for what would become the CSIRO Wi-Fi patent. Now, why I love this story is not just because we saw hundreds of millions of dollars from royalties going to CSIRO to fund more science, but it was the fact that the work John did, the foundational work, was not at CSIRO. It was in a research organization, Dwingelo, in the Netherlands. He was just an astronomer trying to look a little better, a little deeper into the universe. The challenge of it drove him to innovate, and then through CSIRO later on, the framework was placed around to take the early TRL innovations on their journey to ultimate commercialization. And I think this is the story of economic advancement we should bear in mind. John did not create Wi-Fi by design, not at the start. It was foundational, fundamental blue sky research. It was to find exploding black holes. Now, I've made the argument that space is a fantastic vehicle to try to develop skills. And we've heard earlier the importance of generalized skills. The Economic Forum's most recent Futures Jobs Survey lists the key skills that companies are asking for. And what I find extraordinary is the top 5 don't mention anything to do with the technological efforts of the company itself. That's number 6. So the top 5 skills are everything but the technology piece. So how do we train the students in, say, analytic and creative thinking? Well, I'd argue John did incredible work in that regard during his fundamental research and discoveries. Resilience, to be honest, I think the lawyers at CSIRO ended up having more resilience experience as a result of their filing of numerous patent claims and chasing the money out of very large corporations across the world. But this kind of style of learning additional skill sets, including curiosity, lifelong learning, building the appetite for learning, that is what companies are asking for us as educators to provide. So how do we do that? Well, I will argue, not surprisingly, that it's through space. But in particular, it is project-based learning. Now, we have a range of activities across the world, across Australia I could point to, where we're working with companies, but I actually want to look the other way. And I'm really proud of this program at Swinburne. Virginia Kilbourne, Rebecca Allen kickstarted this. And it works with high school students to develop a research project to fly aboard the International Space Station. And then they build it. Now, we have our undergrads and our postgrads mentoring them through this journey. So we set up multidisciplinary teams, and we see an incredible growth in the student sophistication and professionalism of their learning. There's a range of science efforts that are postulated, from growing chia seeds, testing for tooth decay in 0G. What I find fascinating about this program, the students pick the topics. We get 50-50 gender representation without trying in this program. By having an impactful goal. Yes, it's cool, it's the International Space Station. But it's the freedom that comes with defining the research program and knowing that there is meaning behind it and that you could fail. In fact, notably, one of these year groups did. Now, we've extended this program nationally, recognizing we don't want to have it just constrained to the metropolitan area of Melbourne. So schools nationally can now participate in what's known as SISIC, the Swinburne Youth Space Innovation Challenge. All right, so that's well and good, but everyone needs a job, right? So what are those jobs of the future? So we go back to our friends at the World Economic Forum. Top, fastest growing jobs? Wow, that's out of focus. So AI and machine learning specialists, no surprise. FinTech engineers are up there. What's important about the pursuit of space sciences and universities and research organizations is that you do these things to get your answer. You learn these skill sets and apply them to do the work. You are not a data scientist. You are not undertaking a computer science degree. You gain those skills through incidental learning. The need, indeed, drives your learning. Now, I just want to make a point of caution. The best way to get a FinTech engineer, certainly the quickest, is not to study astronomy and do a PhD and then, so clearly that's not the optimal direction to become a FinTech engineer, but astronomy, space sciences is a beacon. It does attract people into STEM, and on their journey through, they decide, maybe this career path in academia isn't for me. I want something else in my life, and I want to start with a multiple six-figure salary, and off they go. And many of our astronomy graduates, space science graduates, are following exactly that path. I know you're all wondering, as I was when I was reading this, where are we in the university sector? We're actually 37th of the fastest growing sector in the world, which I was pleasantly surprised by. And I suspect perhaps the World Economic Forum got an early leak of Mr. Clare's Accords draft, because 34th, in recognizing its focus on VET, is of course vocational education. Now, rightly targeted because when we look not at the fastest growing job segment, but the largest jobs, those are, not surprisingly, vocational aligned. But here I think it's important to recognize too that space drives the skills development across higher ed and vocational. In fact, I was speaking to some of our rocket companies recently in Australia, and their challenge is not aerospace engineering. Literally, they have enough rocket scientists. What they don't have are welders who are certified up to the level needed to build rockets. And as a point of warning, by the way, that's one level cert down from subs. We're going to need a lot more people building subs than rockets, and even that is a tight labor market. It's just a point of concern. Now, jobs, there are aplenty in the space sector. So even those who pursue a career directly in the space sector certainly have an exciting future ahead, as the KPMG report, the Prosperous Futures report for space showed. We will see a rough doubling in the value of the space sector to Australia's economy, about $10 billion. Now, what is that value? Because exciting as it is, student experiments in the space station is not technically, I think, a driver of GDP, or at least not from the productivity chat I heard earlier in the panel. One of the most valuable things that we can do with space is precision positioning, or precision navigation. And here Australia is a leader. This is an initiative known as Southpan. It involved augmenting the satellite signals from GPS with something on the ground. This was a case study undertaken by Frontier SI, EY, and Geoscience Australia. It has now been funded and is essentially operating now as Southpan to deliver 10-centimeter accuracy in Australia. What that means is your Uber Eats delivery can go to your left hand or your right hand. I'm so happy that person's laughing. That was awesome. Now, clearly, that's not a great business idea, right? I'm not saying that's the best possible use of 10-centimeter accuracy. Probably drone delivery of, an EpiPen or an emergency cardiac shocker. I'm also not a medical person either. These opportunities, though, will only be realized if we are forward-leaning and if universities are working together with industry to be ready for this capability. Now, the capability is so accurate, we have to take account for tectonic drift. In fact, we had to update our maps most recently with a 1.5 meter shift because of continental drift. So this is an extraordinary era of precision. Please sign up for Southpan if you want to know more about that. But this is just one example. We do Earth observation imagery. We've got wonderful companies across Australia doing in-flight orbital maintenance, robotics. Fleet is doing seismic activities for mining, relaying the information via space. So good, they're now going to go to the moon to do the same work for NASA. Right, so we are doing extraordinary work in the space field, and the challenge is driving us. However, it all still comes back to astronomy. Because in the same way that our position is known relative to the GPS satellites, their position is known relative to feeding black holes at the edge of the observable universe. And I kid you not, this is called the International Celestial Reference Frame. So again, astronomy, the foundational sciences, comes back as a key driver of our national prosperity. Very quickly, I'll end the search for dark matter. This is a simulation I created a while ago. The red is the dark matter, mysterious stuff whose gravity drives the gas, in blue in to form stars, in white, which we can then see with our telescopes. So the universe we see is the tip of an iceberg. 5 times more of this is this invisible dark matter whose nature we do not yet know. As was mentioned, I'm part of the SABRE program. This is a 10-ton vessel that's sitting in the SABRE assembly site at Wantirna in Swinburne. This is a vet arm of Swinburne. Because if you're going to handle 10 tons of steel, you're going to want to talk to people who know what to do with that much material. So we have this wonderful collaboration, a program led by Elisabetta Barberi of UniMelb, involving ANU, University of Adelaide, Swinburne, and Sydney University. And it's a great collaboration that is going to the bottom of an active gold mine, as was said, which is now operational in the Stawell Underground Physics Laboratory. The reason we've gone 1 kilometer underground is to escape particles from space, known as muons, which come crashing through the atmosphere. They can travel hundreds of meters through the rock. But if you place a detector of those muons beneath that rock, you can use them like an X-ray scan of a mine site. And that's exactly what's come out of that program. At Swinburne, we spun out this technology as M-Detect, and we're deployed, in fact, most recently with BHP, using these detectors to scan one of their sites. And this is the 3D density of their walls, seen by particles from space in a technology that was developed as a byproduct of a search for an invisible ghost-like particle. That's a terrible funding model if you wanted to get to the scanning technology, but it's a very important way to develop new, groundbreaking technology you couldn't have anticipated. And that's the point I want us to end on, that space is hard, it drives us to excel, it excites us to learn and do more. And it is that challenge that will allow us to innovate our technologies and develop new opportunities for the nation. We will be a healthier, wealthier, safer nation through space, but only if we commit to its long-term funding in just the same way as we've done with the SKA. We need to do so for other programs in space. Thank you very much.
Thank you, Alan. That was inspirational. We've got a limited time for questions, but please enter your questions through the app if you can. One of the things that you mentioned, and this is in the first question we've got here, is the attributes we're going to need for graduates of the future, okay? And they may be doing astronomy or whatever else. And the question poses, how is the best way of teaching to get those attributes? Now, presumably you've experienced that. We have large classes now, and it's not like going to an Oxford college, as we heard earlier, where there might be one person to the tutor. But should we be looking at small classes and problem-based learning more to develop those attributes?
Look, absolutely. For me, it is all around the centrality of the problem and the ability to come together and work as a team. I actually don't think the one-on-one is great, because that's not what your workforce looks like, all right? That's a very weird scenario. In fact, if you're going in one-on-one with the boss, this is probably trouble afoot. That's probably how you get fired. So this point of training together, understanding how to bring each other's skill sets to bear, that can only be learned through practice. So I would absolutely agree on that. Perhaps in terms of scalability and scaffolding with the learning, you can have that as a program and on opportunities that are being presented by industry, for example. And at the Swinburne Innovation Studio, they do exactly that. They're taking ideas offered by industry, and they do a series of design challenge and sprints and try to develop those concepts and get a industry standard output at the end, knowing that they're meeting an actual need. And I think the critical point is these projects cannot be make work. Students are smart. They know when this is a problem that's being solved. You know the answer as a teacher. They know that you know. It's not a genuine learning experience. At best, I mean, maybe they'll try to learn the techniques, but it's not the same excitement as a journey together to discover something. And I think it has to be a genuine learning experience, and they have to be able to fail. Quite literally. They have to be able to show you how they've learned from the failure so that they still pass the course, but failure has to be an option.
You made quite a compelling case for why our interest in space and our exploration and our need to discover has driven all sorts of different technologies and moved a lot of things forward. And it clearly has had huge impacts on the economy of the world. Where does Australia sit in this? I mean, do we invest sufficiently in space? Yes, we've got the square kilometre array, but that data is available to everyone around the globe, and we may not be doing much analysis. I don't know. Maybe you can indicate that. But are we doing enough in space? I mean, we always think of NASA, and is there any relationship with them? Where are we? Are we a minor player or a major player?
So we're very much a trusted partner of NASA. They have a large number of their so-called deep space receivers. When they return to the moon as Project Artemis, just as we did with Apollo, we will be taking some of that signal back. But we want to go beyond that, and we will return to the moon with NASA with the Australian lunar rover. So we will be driving on the moon, trying to demonstrate how to mine it. Because once you land there, you want to live there, and you want to access the water resources, particularly of the moon, to sustain human presence. And remote operations is one thing that Australia does very well. So it's certainly, when you look at the mine sites, Pilbara to Perth, Perth to the moon at the speed of light, that's not too much of a difference. So I think we have a lot to offer. But the problem is we are not seeing the significant levels of committed investment that galvanize not even a nation, but as interested members of society to commit their lives to years of study and work because they know there's something big and exciting. It's not enough to say space is cool, general waving of hands. You have to have something very concrete, a mission-based approach. And we can do this in Australia. Arguably, we must if we want to see people put the time in to develop the skills that are needed in the rest of the economy, much less the fact that we directly benefit from missions much closer to Earth, the Earth observation fleets. We can detect bushfires, for example, from space. This has been long advocated for. We're in Canberra, so this is ANU, has done a lot of great work demonstrating this. That is wild to me that we don't have a bushfire satellite. We rely on other countries to tell us where we're burning. Yeah. That doesn't sound right.
Just because of time, I think you've kind of addressed one of the questions, which was the importance of blue sky research, which you can't get more blue sky than
beyond the blue sky, arguably.
But there's one final one, and we don't have a lot of time, but it is an important
Let's just run late, Steve. It's all right.
I'm kind of worried, but we could do. We'll see what happens if they come in and take us away. But in the context of science and technology more broadly, and you pointed out that the square kilometre away is on Aboriginal land, of course.
Yep.
Do you see the potential for Indigenous knowledge and/or Indigenous knowledge systems to be involved in, and what are the pros and cons?
I love that you've done that with just running out of time.
And you've got 51 seconds.
Yes, there is a need, and it's a great opportunity. There's incredible work by Indigenous astronomers. Carly Noon has written a wonderful book recently on this, where we can, if we take the Indigenous stories that we are allowed to be told and publish in Western scientific literature, of course, and we can correlate those events of meteor strikes and of other events in the sky. And if we actually trust that knowledge system as Westerners and go looking for the answers, we always find a causal effect. So the recognition has only come recently in the West that there is this deep well of authentic and accurate information that we could all benefit from. But then moving forward, the opportunity is to work collaboratively and learn from each other. And I'm very proud to say that CSIRO and Swinburne have an Indigenous fellowship stood up recently on using Earth observation imagery to better understand Australia, in particular regional Australia, and who better than the Indigenous peoples of the area. So that's where the targeted fellowships are going. So those kinds of activities take time, and it takes a lot of trust, and a particular lot of trust on for the Indigenous knowledge holders. And that's where it can fall down, where not sufficient respect or understanding is paid to that deep well of knowledge.
That's great. Probably you don't see this, but there's a horrible red thing flashing at me, which is threatening all kinds of doom if I don't end the session now. But look, we've had a fantastic exposition from Alan, and I'd like you all to show your appreciation.
Thank you.